We talked about similar triangles only a couple chapters ago. Okay. Question?
I just want to make sure, isn't arsenic considered?
I don't know.
Is it a poison?
I don't know. Honestly, I don't care.
What's arsenic?
Okay. I want someone to give me another proportion besides this one. Colton, you have just derailed the entire class when I just got them back together. So when I asked you, do you have a question? I was meaning about this. Okay, give me one of the proportions that you have written down.
AD over CD equals CD over DB.
Okay, that was really fast.
Thank you.
Can you do it again so I can?
AD over CD equals CD over DB.
CD over what?
DB.
That's very interesting, that one. Why do you think that I think that that's interesting?
Because it's double CDs.
Ooh, it is double CDs.
Whoa.
That's very interesting.
Yeah.
No.
No.
No, not even close. Okay. I need another proportion. Who can give me another one? Jake. Okay, are you talking about these two triangles right here?
I have no idea. It's just on my page.
Okay, the big one and the medium one. So here is AC over, it would correspond with AD, right? And then what is the other side that you picked?
I think it's wrong.
So let's pick like CB. If we pick CB, then in this triangle, we need to go from right angle to here, so DC. Okay. You're ready for your homework, right? Because you're not listening to me. That's what that means?
I'm not.
Do you know what geometric mean is?
No.
So stop talking. It's nope. Not geometric mean. Okay. What's another proportion? Ben, do you have another one?
DC over DB equals AD over DB.
Equals AD over what?
BB.
Okay, DC over DB equals, what did you say?
AD over BB.
AD over, I think that you would have to put CD. Hold on. DC over DB equals
AD over CD.
AD over CD. Another one with double CDs. Interesting.
Well, I think I know why.
Like that? Okay. How about BC over AB so here is AB and here is BC, right? Yeah. Over equals BD over BC. How do you feel about that proportion? Yeah. Interesting. Another time we kind of doubled up. Do you think that this means something? Okay. It means something. Okay. Because CD is the altitude of our right triangle, some interesting things are happening. So how about, let's go ahead, keep this out, but I want you to turn in your student journals quietly to page 254. No noise. Student journals 254. Cohen Tyler. I'm sorry, Tyler, your laugh is very loud and I can tell it's you very easily. Very unique. Distinct, that would be a better word for it. Okay, remember when I said quiet, Jake? $2.54. Okay. I would. Okay. So what we just worked with on that sheet of paper was this picture right here. And we talked about how we could break this up into 3 triangles that are similar. Okay. And my suggestion to you would be to kind of paint a picture like this, where you can see which angles are congruent so you can set up your proportional parts. Okay. And you can set up your similarity statement. So we could say that triangle A, B, C is similar to triangle A, C, D is similar to triangle C, B, D. Okay. I went from pink to blue to right, pink to blue to right angle, pink angle to blue angle to right angle in my similarity statements. A, B, C, A, C, D, C, B, D. Okay. Okay, so this angle right here is this guy. Well, if this is a 90-degree angle, and angle A, let's just say it's 20 degrees. Yeah, okay. Now, we need to learn what's called a geometric mean. What I want you to do is I want you to circle this right here. Okay, it's at the bottom of 254. This is the geometric mean. So if I ask you to find the geometric mean between 2 numbers, you're going to set it up like this, to where the number that you're finding, they're crossways from each other. Okay. So if I want to find the geometric mean between 4 and 9. Well, the geometric mean is what I'm finding. So I'm going to set up a proportion where my geometric mean is catty corner from each other. And my other 2 numbers fill the rest of my proportion.
But how does this relate to like what we were doing yesterday? Like
No proofs. Okay. Now, I would like to point out that today in Flex, a student asked for some help on his graded worksheet. And I said, hey, how about you get out your notes? Well, I just really want you to tell me how to do it. Well, that's not helping you learn. How about you get out your notes? And you know what happened? They didn't take very good notes, and they had a hard time figuring out how to do the problem. Doesn't matter. If you aren't writing this down, you are doing yourself a disservice. Okay. Now, what we are going to do, I just said, it doesn't matter who it was. So now I am going to cross multiply. X squared equals 36. So what's X?
36 squared.
The square root of 36? Okay, so how about you find me the geometric mean between 3 and 15?
Wait, so, I have a question.
Yeah.
Just back like the 4 and the 9, when you cross multiply, there's 90 x squared over. Oh, so it's equals.
We need to do the 4x over x over 90 and like always, or can't we just multiply?
I mean, you can write x squared equals 45. Okay,
I got it.
I want a simplified radical.
Wait, now I
Okay.
know how to make it simplified. That's what I asked. X equals 3, how would you raise? And then-
Okay, so we can write 3 over x equals x over 15. So Colton asked, can I just go straight to x squared equals 45? Technically, yes. Okay. Okay, so then when we square root both sides, you simplified the square root of 45, right, Cohen? What did you simplify it to?
3 radical 5.
Do you agree with 3 radical 5? Okay, so now, why are we talking about the geometric mean? Okay, if we go back to here. Do you notice in those proportions, how across from each other, we have the same segment?
Oh.
Me too. Wait. For math.
That's what about the dark one?
Meh, it's not important.
So BC equals, well, how do we get that?
Okay, so go to the next page. The altitude of our right triangle is the geometric mean between the two lengths of the hypotenuse. What does that mean? Okay, if we go back to like one of those proportions that we wrote down, we had CD twice, catty corner from each other. So what's happening is, I'm going to label it as X. This guy is Y and this guy is Z. So Y over X equals X over Z. X, our altitude, is the geometric mean for these two cute little hypotenuse segments. So should I draw a triangle to help us here? I will. Okay. Do you see that we have? Hold on. We have a right triangle and I've drawn an altitude. Do you see it?
Yeah.
I'm telling you that the altitude has a measure of X, that this segment has a measure of 10, and this segment has a measure of 2. Okay.
2 squared root of 2. What's the 10 plus 2 squared root?
No.
20 is.
So this guy is the geometric mean of these two numbers. So we can set up 10 over X equals X over 2.
How did you get here?
I told you that that's what the numbers were. This is like, here is your given.
No.
This is like, here's a problem. Here's an example. The pink triangle with the purple numbers would be like a problem that you have written on your homework or your quiz or your test, okay? If you have whatever your altitude is the geometric mean between these two pieces. So we have X squared equals 20. But the square root of 20 is the same thing as 4 times 5. So 2 square root 5 is the answer I was looking for there.
90. Dude, you got it right.
Let's not think fast, okay?
Yeah, I was wrong.
Okay? Now, how is this helpful? Notice how, if I try to do the Pythagorean theorem of this triangle, I don't have enough information. If I try to do the Pythagorean theorem of this triangle, I don't have enough information. If I try to do the Pythagorean theorem of this triangle, I don't have enough information.
Oh my gosh.
Yeah, so it depends on when it gets there.
All right, so now, I have more great news. The sides are the geometric mean. Oh, it is good news. Okay, so this guy here, I'm gonna call him X. He is the geometric mean between this side and this whole side. This is the geometric mean between this little cute piece that's a part of the same triangle and this guy here.
How do we solve it? We don't know what the fuck
Can you just like, can we talk about it and then do an example with numbers?
You just said solve the problem.
No, I didn't. Okay, and then this guy over here. This guy is the geometric mean between this side and this whole thing. Do you see how there's that symmetry there?
Yeah.
How I like, hey, here, we take these two. Hey, this guy here, we take these two.
Would like tell you like that's the geometric mean of Y and Z.
You have to figure that out. Now, here's the thing. You don't have to know anything about geometric means if you don't want to in a picture like this. Because like Zach said, couldn't you just set up a proportion? Or I don't know if that's what you said, but that's what I'm interpreting that you said. You could look at the similar triangles and just set up a proportion. Because not all the time is it going to be a geometric mean anyway. If you have similar triangles, you can set up proportions. However, if you recognize, like in this picture that we are going to draw together, that's a terrible picture. If you recognize that we have a geometric mean, then it is a lot quicker, okay? I think this one looks pretty good. Oh, okay.
Oh, then we have to do Pythagorean.
So, no, we don't have to. Because this is a geometric mean of 9 and 12.
I thought the
So
opposite.
then you do the cross multiplication.
Oh, 108.
Okay, that makes Oh, yeah.
108.
Hold on. Hey, hey. So when I cross multiply, x squared equals 108, you said?
Yeah.
Does 108 have a nice,
Yes.
64.
You can do four. Four 27 times. You also-
27 has a perfect square then? So how about,
Oh, wait. Yeah, so 4 times 27 equals 108. So then, and then,
so how about 36?
and then 9,
Yes.
Put it down.
Yeah.
and then,
Oh, man.
You know what? I understand it. You're excited, so you want to stand up. Tyler loves math. Okay, so Tyler was really excited about 4 times 27, but 27 still had a perfect square in it, so we had to keep going.
yes, that's all.
Okay. Hey, hey.
Me too.
Oh, I'm so sorry. Carson, go when he gets back. You can go. I got so excited about math. All right, so I want you to look at number 5 on the next page. Number 5. Make 5.
Tyler thinks he's
Yeah,
out.
just to make sure. Right, turn around. Okay, the noises, not helpful. You are just so excited
He was
today.
really talking to me. You cannot believe it.
Did I say Tyler runs so mad at you?
Oh, you're
Yes.
staring at me.
I thought you did.
We do have the power to ignore.
Sorry.
Okay, so here we go. In this problem, do we have a geometric mean? Yes. We know that the altitude is the geometric mean of the two cube pieces of the hypotenuse. Okay, so we can set up 16 over x equals x over 9. Right.
So don't really need to know the theorems, or you just like put those two numbers over each other.
Yeah.
Each of those like three.
Okay, so here's what I would need you to remember. I would need you to remember that this segment is the geometric mean of these two. If you can remember that, then you can set this up and you're good. Now, if you didn't have those pieces, then you would have to set up similar triangle proportions. Okay? All right.
Yeah.
Sure, you were
So X
talking.
is equal.
Cohen, are you being my talking police right now?
Yes. No, I was just understanding if Bryce was talking. And he wasn't. He wasn't.
Does it matter?
No, I was just.
What's 16 times 9?
144.
Oh, that's so great. Okay. So now let's look at number 6. What I need you to remember is what geometric means piece together. So we know that if we have the altitude, then one of these, like outside one of the legs of the big triangle, is a geometric mean between
What?
what?
But what if you like between us and then?
Yes.
Wait, is it 3-2?
So this guy is the geometric mean for these pieces, 9 and 11. So 9 over y equals y over 11. It's the whole hypotenuse. Okay? So here's what I would remember, okay? If we're looking at the two little triangles, we are taking the hypotenuse with the leg and the giant triangle's hypotenuse. See that?
Wait, so it's 11.
Boom, boom, boom.
What, why? Is it 311? Is it 311?
Radical 11.
3 radical left, yeah.
This is how it is. This is how it is. Like, how do you know?
Like, it's like 33.
Yes.
Like, how do you know it's 9 and 11?
So I know that 9 because it was given to me, and then I got 11 because I added 9 plus 2.
Or just like, how do you know that's like what the mean is? Like, how do you know those are the two numbers in here?
Whoa.
Because of this right here.
That's just how
Okay.
it is.
Yeah. Now, if you don't like trying to remember which one's the geometric mean, then set up similar triangle proportions. Because that's all this is. This is just a like kind of a shortcut. Okay.